an inductor of inductance L equal to 400 millihenry and resistors of resistance 2 ohms each, right? This is the resistor, these are the two resistors, and this is the inductor, right? Are connected to a battery of EMF 12 volts. Now this is 12 volts basically, this is 2 ohms and this is also 2 ohms, right? And this is basically 400 millihenry. The internal resistance of the battery is negligible. The switch is closed at t equal to 0. Now this switch is closed. The potential drop across L as a function of time is. Now we have to calculate the potential drop across this thing, right? So how do we solve it? First of all, if I use basically Kirchhoff's loop, right? If I assume that I2 current is flowing in this, so using Kirchhoff law, E equal to L d I2 by dt plus I2 into R2, right? Now what is the initial current? Initially this will behave, we know that this behaves as a short circuit. That means plain, it does not show any resistance. So that means initially I0, if we assume that this is short circuited, I0 would be what? I0 2 basically, right? This will be E by R2, right? So this will be equal to what? 12 divided by 2, which will be equal to 6 ampere, right? Now I got the I0 value. Now this is basically during the circuit. What will happen? We know that the formula is given by I2 will be equal to I0 into 1 minus e raised to power of minus t by tau, right? Now tau is the time constant. In this kind of a circuit, how do we calculate the time constant across the inductor? What do? We basically short circuit the EMF basically, so and calculate the net resistance across these 2 points. So if I see this wire has 0 resistance, ABC. If I talk about now wire ABC, resistance of ABC is 0, but resistance of AC is R1, right? So what will happen? The net resistance, these two are in parallel, net resistance will be 0. That means across this ends, the total resistance R net will be what? R2 only. That means 2 ohms. So to calculate time constant, we write L by R, where R is R net. That means L by R1, R2 basically, right? So tau I can write that it is L is 400 millihenry. That means 400 into 10 raised to power of minus 3 divided by of 2, which will be 0.2, right? So I2 will be equal to 6 into 1 minus e raised to power of minus t by 0.2, right? This is I2. Now what is the potential drop across the inductor? It will be E minus I2 R2, right? Potential drop across the inductor, it will be this, because total potential drop across the entire wire is E, and some potential drop there will be across the resistor R2. So this will be the net potential drop. This will be equal to what? 12 minus 6 into 1 minus e raised to power minus t by 0.2 into R is 2. So this will be 12 minus 12 plus 12 e raised to power of minus 5t. So basically these will cancel out. So that means 12 e raised to power minus 5t volts is the answer. That means option D is correct. So this was basically, as you can say, that it was a relatively easy question, but you have to know the concept of how to calculate the time constant, right? And what is basically the potential drop across the inductor, right? And basically this formula as well, which is of the charging of or the current flowing through the inductor. This formula should be known, right?